Alrighty, in this video we're looking at simple harmonic motion. So this is sort of your swinging pendulums or swinging springs. And if you're familiar with physics, you'll recognize that as Hooke's law, hopefully. We'll write it as d squared x over to t squared is minus k squared x. I want to talk a little bit about where this comes from. You can sort of imagine like a pendulum swinging. Now here would be x equals 0. Something out here might be 5 centimeters to the right. Then something out here might be minus 5. Now you can sort of imagine that as we're going past 0, that's when we're going to be at a maximum velocity. We're going pretty fast past that. But anything to the right is going to be pulling it back. So here I want to pull it left. And you can sort of imagine this like I would want my acceleration to be negative. And so that's exactly what happens. Acceleration is negative k squared times x, where that k squared is just a constant. So you can see as if you're getting stretched out further and further, like 5, you get a negative number. But if you're at x equals 10, your acceleration would be even more negative. So the further out you go from this center point of a pendulum, the more you're getting pulled back until eventually you get pulled back so much that you swing back the other way. There's a whole thing in the textbook about solving this differential equation. I won't go into that now apart from telling you what the solution is. It's a trig function, unsurprisingly. So let's do this example here, and we're going to just be plugging in our trig function. So x equals a cos kt plus alpha. So a cos of kt plus alpha. Now, really importantly, the alpha is the angle where it starts, and in our case, alpha is 0. So alpha is 0 because it starts at the extreme positive position. That's good. To figure out k, we know that let's see, the period is 2 pi over k. So period is 2 pi over k. Therefore, k is 2 pi over the period. In our case, for this question, the period is 2 seconds. So that's pi for our k value. Now, our amplitude is 0.7. So our actual function here, x as a function of time, so position as a function of time, equals 0.7 cos of pi t, or pi t plus 0, but realistically, just pi t is fine. This next example we've got here, so an object is oscillating under simple harm motion with amplitude 5 and period 8 seconds. We want to find the speed at which the object is when it's 3 meters to the left. So here we're actually not going to use the general form. I'm going to use this handy identity here. So v squared equals k squared, brackets a squared take x squared. And that sort of falls out of when they were proving that this formula is true. But we can just use this. So v squared is going to be, so k is related to the period. So k is 2 pi over the period. So in our case, the period is 8. So we're going to get 2 pi over 8, or pi over 4 for our k value. We know the amplitude is 5 meters, so we can write that in. And we want the speed when it's 3 meters to the left, so this would be x equals minus 3 to get our speed. So essentially, the velocity squared is k squared times a squared take x squared. We know what all those numbers are. So that's going to be pi over 4, all squared, times the amplitude, so that's 5 squared minus 3 squared. Now, really importantly, we actually don't know what direction this is going with our velocity function. So you'll notice the minus 3 squared. It wouldn't matter if we were at positive 3, because you can sort of imagine a pendulum if you're in the middle spot. So if you're out here versus out here, you would be having the same speed towards the center regardless. It's just one's positive and one's negative. So that gives us pi squared over 16 times 25 take 9. Which I believe is pi squared over 16 times 16. That actually simplifies really nicely down to pi squared. So that's our velocity squared. Now the speed is the modulus of velocity. It's like the absolute length of velocity. It doesn't matter whether you're positive or negative. And it just so turns out that that's the square root of v squared, because that will always just end up being positive. So the speed is the square root of pi squared, or in other words, speed is just pi. And we should put some units on this, pi meters per second. And that's how you can do one of these questions without actually figuring out sort of what the position function is and then doing all these derivatives and everything. So it's good to have that handy identity on your cheat sheet.